We'll look at one more example of designing a combinational circuit. The case I have taken here is the full subtractor. So step 1, listing the objective. What is our objective? We have 3 inputs given to us, x, y, z, and we need to formulate a circuit which gives us 2 outputs, the difference and the borrow. This is our objective. Our second step is to identify the number of inputs and outputs, which, as I have written down here, is clear from the objective. So in the third step, we list out all possible combinations of inputs and specify the corresponding values of outputs. In other words, we draw the truth table, which is what I have done here. So since we have 3 inputs, we have 2 raised to 3, which is 8 possible input combinations ranging from 0, 0, 0 to 1, 1, 1. And for each of these, I have specified the difference and borrow values. How do you get these values? You subtract x minus y minus z by following the laws of Boolean subtraction. So this is the truth table we have. Now our fourth step usually is to develop an expression for the outputs in terms of the inputs. So we need to derive d in terms of x, y, z, and similarly b in terms of x, y, z. Now because we have 3 input variables and 8 possible combinations, looking at the truth table and directly deriving an expression is not going to be the easiest thing to do. Instead, what we do is we draw a K-map. You can also use the Cohen-McCluskey method or any other method which you are familiar with. Here I have chosen to go with the K-map method because it is simple. So this is the K-map for x, y, z. And as you can see, the combinations for which d takes a value of 1 are 0, 0, 1, 0, 1, 0, 1, 0, 0 and 1, 1, 1. And those are the corresponding values for which I have marked a 1 here. In this K-map, as we can see from the arrangement of ones, it is not possible to do any grouping or simplification. So we take the 4 terms as they are. Now we apply the laws of Boolean algebra. You take out the common terms and factorize. You will get x into y dash z dash plus yz plus x dash into yz dash plus y dash z. Now before we proceed, let's just take a minute to recall these 2 laws which I'm sure we might have studied. A XOR B is given by AB dash plus A dash B, and A XOR B the whole complement, which is nothing but A XNOR B, is given by AB plus A dash B dash. So coming back to this expression we had, you can see that this is nothing but Y XNOR Z and this is Y XOR Z. So that's what I've written here, x times y XNOR z plus x dash times y XOR z. And again you can see this is something into something complement and the first thing complement into the second thing, which is again of this form. So it eventually boils down to x XOR y XOR z. How did we derive this? A quick recap. We got this expression from our K-map. We took the common terms out and we got this expression. Now using these 2 laws, we derived this to be y XOR z and this to be y XNOR z. Again, using the first law, this one simplifies to x XOR y XOR z. Now if you try a similar method with the borrow, which I am not doing here, I will leave it to you guys as an exercise, you will get this expression. And so now we have expressions for d and b in terms of the inputs. All that is left to do is draw the truth table. So you have x, y and z, and I've just connected each to a NOT gate, so you get x dash, y dash and z dash. Now you take x, y, z, all 3, connect them to an XOR gate, you will get your difference. For the borrow, we saw it is x dash y plus x dash z plus y z. X dash y connected to an AND gate. Again x dash z, they are connected to an AND gate. And here you have y, z, they are connected to an AND gate. And all 3 of these are connected to an OR gate, you get the borrow. So this is an overview of your full subtractor.